That's the famous thing, you know, at least for the architects, or for the architects, for the athletes. In Cincinnati, however, McGill-Smith Punchin, Randy's company, was able to implement an innovative and thought-provoking all precast design that outperforms traditional block, brick, and steel construction.
Steel industries was so overburdened you couldn't find good contractors. And it was a real problem in terms of both schedule and quality of products being delivered to the schools. After we had gotten through schematic design and we were significantly over budget, that's when Katrina hit. There was a lot of market impact on the oil industry and prices shot through the roof. They had to really rethink it because it was not only over budget, but the schedule for this particular site, it was a two-school site. The existing school that was on the site was going to be used for swing space. So getting the people out of this existing school into their new school was really critical for many projects down the line. So the local precasters were doing a great job of soliciting OSFC to get precast into school systems manuals for allowing us to use it. I mentioned this before, but you know, one of the things we talked about, not just doing the architectural precast on the exterior wall, but we wanted to make it as much precast as we could. We wanted to eliminate steel. This project as much as we possibly could.
And you were able to achieve your goal?
The only steel in the building is the sloped roofs. Everything else is precast. So the local precasters were very instrumental in helping me understand how to do that. What the flexibilities were, what the connections were, help my structural engineer get a comfort level of how to do all these things. And we really pushed the limit. You know, we wanted the interior walls to be precast. We wanted this thing to be built as a kit of parts and erected quickly. So we really pushed it. And the interior walls, like Jim had mentioned before, are like drywall. When you paint them, it looks just like drywall. You have to knock on the wall to find out what the differences are. So I will give the local precasters a lot of credit in helping us understand how to do what we do. Right? I mean, basically, all the exterior walls went from 15 to 11. That's 4 inches across the entire perimeter of the building. That's roughly 1,000 square feet in this particular case. The other aspect, by using interior precast, by pushing that envelope a little bit, we saved another 2 inches of space on interior. Now, when you're looking at a school design, you know, it's a prescribed square footage. The state says you must have this, and you must be within a certain percentage. They also give you what's called a construction factor. The construction factor is your wall thicknesses. So there's only so many things you can play with. They have prescribed net spaces that you have to give them. There are some areas you can play with. Corridors are one of them, construction factor is the other. How much exterior wall do you have, and things of that nature. So as you're trying to be creative on how you solve those things, what was a sort of an added benefit to using precast was our ability to reduce our overall building footprint and actually giving them more square footage of usable space. We were actually, you may go through this, it's in the article, but I think we were actually 1,000 square feet under their program of requirements, and we actually gave them 1,000 square feet of additional usable space. So the net was about 2,000 square foot of difference. And it was nothing, you know, up my sleeve. It was, that's the way it turned out.
I know how important it is to you architects. Every time I ask for a little bit more room, you say no.
Well, the construction factor for a typical OSFC funded project is 11%. That's what they have in their calculations, and that's what they count on you to have. Ours was down to 6%. That's an incredible. I mean, when you think about being good stewards of your resources and designing for effectiveness, that was a huge impact. They had a specific neighborhood preschool program that was not included in the OSFC program requirements, and so they were really at a quandary of what they were going to do. We had to either drop the program or find a way to give them an extra room. Precast allowed us to do that. So on the Academy of Languages, we were able to give them an additional pre-K room, 1,200 square feet, that was not in the program, and we were still below the overall gross square footage. Again, by using thinner walls, effective use of corridors, and effective design, they got an extra classroom out of it. And typically you need about 13 for it. So we were able to reduce our exterior wall and floor-to-floor height by using hollow core. That was a significant savings as well. One of the things that we were told that when we started designing schools is Turner Construction uses called the floor-wall ratio. And if your floor-wall ratio is in the 0.45 range, that's where they want you to be. If you're higher than that, you get too much exterior wall. So our challenge was to reduce to help with cost as well. And I think on this particular project, we were down to like 0.39. There's some other aspects that are intangibles to using precast, which it became apparent as you walk through the site. Not only the term, it was only about a 10-week erection period. The building was pretty much dried in. And that was forcing the steel guys to keep up with them. One thing that was amazing to me was how clean the site was. And there was hardly any cleanup. There was no debris. There was no scaffolding to mess with. There was no mortar to clean up. I don't know if Turner ever looked at the general conditions number and say what impact did using precast have on that. Had to have some effect. The amount of cleanup was almost minimal to none. The ability to have electricians come in and pull wire and not have to wait for our mason to build the wall up, tremendous. Now, whether or not the bids really came in and took advantage of that, probably not. Being the first school, I think previous schools have taken advantage of that, the second and third one that was done. The HVAC guys, they have a clean ceiling. There's nothing in the way. So those are the kind of things that are intangibles that are hard to measure in terms of dollars. But in terms of speed and erection and coordination and collaboration, you force all these guys to come together and work it out versus fight about it later. The main reason I wanted to go to full precast is because we had a schedule issue. If I did architectural precast, I had to wait for masons or whoever else was going to do the structural of the interior. I had to wait for them to build the next level. So it wasn't doing me any good to do partial. I really pushed the limit and did everything we could do in precast. One of the quotes that Vera Brooks, the principal of Roberts, gave me just recently, I asked her what she thought of the building. She absolutely loves it. Has nothing but praise about it. The kids love it, the teachers love it, the parents love it. And one of the sort of hidden benefits is how quiet the corridors are, how quiet when the doors are closed in the classrooms, you cannot tell a classroom is being run in the next room. Right outside in the LA, as this picture shows, you can have a small group run very effectively because there's no sound transfer. With the precast walls, it virtually deadens all sound transfer from room to room. Precast, it really is, it opens your eyes to what you can do. Not what you've always done, but what you can do. And it really is, if you're creative, if you understand the limitations and the possibilities, you can do some pretty cool stuff with precast.